Is 8.6 day 3. We're going to do some operations with radicals. For addition and subtraction, we need like terms, so it must be the same radicand and index. So with this one, they're both square roots, but what's underneath does not match. You cannot add these. This is the answer, okay? The square root of 3 and square root of 2 do not have the same radicand, so this is already simplified. Now, if they do have the same radicand, this is just like adding 2x plus 5x. That equals 7x, right? So similarly, I just add the 2 and the 5, and the square root of 3 part stays the same, okay? Now, if they don't match, but you can simplify a square root so that it will match, then you can do the subtraction. So 27, I could break into 9 and 3, right? So square root of 9 is 3, so I get 3 times 3 minus 5 root 3. So I would end up with 9 root 3 minus 5 root 3. These match, so 9 minus 5 is 4, and then I keep the square root of 3 the same. We can do the same thing with cube roots. So right now, this doesn't match, but if I could get this to be a cube root of 6 as well, then I could combine them. So I want to think what times 6 equals 48, and that would be 8. And that works out great because 8 is something that I could take the cube root of. Cube root of 8 is 2, so we get 3 root 6, cube root of 6 plus 2 times the cube root of 6. So this is really like a 1 times the cube root of 6, so 1 plus 2 is 3, and then the index and radicand part stay the same. Okay? All right, fifth root. So I need a fifth root index, which I have that in both, and I need these to both be 3's as the radicand. So what times 3 would give me 96? That would be 32. Sorry, that should be a 5. Fifth root of 3 minus fifth root of 32 times 3. And the fifth root of 32 is 2. So we have 7 times the fifth root of 3 minus 2 times the fifth root of 3. 7 minus 2 is 5. Keep the index and the radicand the same. All right, when we multiply, we don't need like terms. We can just multiply what's underneath the radical together, but we do want to simplify first if we can. Now, square root of 2 and square root of 3 are already simplified. Square root of 6 is what I would get there. Here, I would do the numbers outside together and the numbers underneath the radical together. So here I would get 10 times the square root of 6. Okay, now we can distribute and multiply here as well. So I'm going to do negative 3 times 4 is negative 12. Negative 3 times this, so I can only do negative 3 times 2, and then the root 2 part is just going to stay. Okay, 5 root 2 times 4 is going to be 20 root 2. And then 5 times 2 is 10. And square root of 2 times square root of 2. Okay, simplify that more in a second. So here I get negative 12. These I can combine, they're like terms, so I get plus 14 root 2. And then here, I'm going to get 10 times square root of 4, which is 2. Okay, because this is square root of 4, which equals 2. Okay, so now I can put these guys together, right? So I've got 8 plus 14 root 2. Cannot add these because this one has a radical with it and this one does not. Okay, let's try another one of those. So 4 times 5 is 20. 4 times 3 root 5 is going to be 12 root 5. Negative 2 root 5 times 5 is going to be negative 10 root 5. And then here, I'm going to get minus 6, and then root 5 times root 5 is 5. Okay? Combine some like terms. So here I'm going to get negative 30 and 20 is negative 10. 12 root 5 minus 10 root 5 is 2 root 5. Okay. We're going to talk about this a little bit more in the next lesson, but we are going to be rationalizing denominators here, which, yep, is the next video, you guys. But just, I'm going to give a quick example here. So let's say I have 1 over the square root of 3. This is not considered simplifies. Rationalizing means get rid of square root in denominator. Okay, and we do that by multiplying by whatever it is. So I'm going to multiply by square root of 3 in both, because I'm really just multiplying by 1. So going straight across, I get root 3 over square root of 3 times square root of 3 is square root of 9, which is just a regular 3. So this would be rationalizing. And like I said, there's more to come in the next lesson.